Okay, so here we are, question 5. Now, after a couple of tricky questions in a row, we're here on question 5, and you look over and you'd see something familiar. Diagram 1 shows the sketch of y equals x squared. Diagram 2, 3, and 4 show the sketch of the graph y equals x squared after it has been moved parallel to the x-axis or parallel to the y-axis or parallel to both. Okay, so let's have a look. Our job is to write down the equations of the diagrams shown in part 1 is diagram 2. Okay, so here we go. So in diagram 2, you can see that we have that our function, our quadratic, has moved up by 3 units. So the equation that we're looking for, the answer that we're looking for, is y equals x squared plus 3. And that's 5 marks.
So this question's on a 0, 3, 5 scale. So partial credit is available for identifying that this graph has moved 3 places up the y-axis. So if you have written down movement of +3 or something along those lines, you can have the partial credit here. The full credit, you need to say that it's y equals x squared plus 3 or f of x plus 3. So it needs to be part of the equation to get the full credit. But if you've identified the +3, you can have partial credit here for 3 marks.
Okay, thanks, Andrea. So hopefully we're doing okay on that one. In diagram 3, what's happened? Well, okay, so the quadratic has shifted 2 units to the right-hand side. Okay, so I'm hoping that you'll know that the answer is x minus 2 to be squared. I imagine some people possibly have a plus there by mistake, but of course, what we know that when we put in +2 into this our bracket here, we get 2 minus 2, which is 0. 0 squared is 0, so the point would be 2, 0. So that's my correct answer, and that again is 5 marks.
So again, this question's on a 0, 3, 5 scale, very similar marking to the previous one. Your partial credit here is for identifying the -2. So showing that you know that that movement to the right of that graph is identified by -2 within the function. So marks here are awarded for y equals x minus 2 all squared, or having f of x minus 2, or actually if you multiply out the bracket as well. So if you had y equals x squared minus 4x plus 4, all of those would get you full credit, and as I say, the partial credit is for identifying that -2.
Yes, so as Andrew said, there are y equals x squared minus 4x plus 4 would get you the 5 marks. Okay, so diagram number 4, we're going up and to the right. So it's combining the first 2 transformations. So we get y equals x minus 2 to be squared plus 3, and you get 5 marks again for that one.
So again, a 0, 3, 5 scale. Partial credit here is for identifying the -2 and the +3, but not putting them into an equation. Now, you can also have the partial credit here if you have the x minus 2 all squared correct within the equation and then make a mistake on the number it's moving up or down by, or similarly the other way around. So in this question, if you had x plus 2 all squared plus 3, you could have partial credit for that. On this question, there is follow-through marks. So because it does follow on from the previous 2 diagrams, if you had those incorrect, but you use them correctly here, you could actually get all 5 marks. So had you had, say, I'm just making an example now, f of x plus 1 for the first one, you had f of x plus 2 for the second one. If you then made this one f of x plus 2 with your plus 1 at the end, you would have all 5 marks here. Okay, so you can get full marks here, having had the previous 2 wrong.
Andrea, thank you very much for that. Okay, so we've 15 marks allocated for this particular part, for part A. So we've 10 marks left, and what do we see? We see y equals the modulus of 4x minus 3, and what we have to do is we've got to state the coordinates of any points where the graph cuts or meets the axes. Okay, so what do we have? Well, as it always says to students with something like this, the modulus of 4x minus 3, I would definitely recommend that if you could, to draw a sketch. I'll just show you that here. I'm just going to click through to draw a sketch. Now you can use your calculator, mode 3 on the Casio with the absolute value button. or mode 2 on the new sharp, and you can actually put in your modulus into the function, and you could start at maybe, maybe minus -2 or -3 and end it 5 or something like that, and you'll get your various values for x and y, and that can help you to plot this function. But even without that, you'd figure out, okay, where's it going to cross the x-axis, or where's it going to intersect the axis? Well, you can put in 0 for x. Okay, so you put in 0 for x. So 4 times 0 minus 3 will give you a -3 or -3. And the modulus of -3 is 3. So that would be the point 0, 3. So that is where it's going to cross the y-axis. So when y is 0, well, what are you going to get? You're going to get the modulus of 4x minus 3 equals 0. Now, we're getting rid of, you can do this in a couple of different ways, but it ends up being the same thing. Now, you could square both sides here to get rid of the modulus sign, or you could take what we call the plus or minus case. So 4x minus 3 is equal to plus or minus 0. But as you know, plus or minus 0 is just 0. So there's actually just going to be one solution for this part. 4x minus 3 equals 0. So 4x is equal to 3, and we get x is equal to 0.75. So this is my answer, 0.75 for the x, 0 for the y, and that's a 5-mark question.
So this is on a 0, 2, 3, 5 scale. There are 3 things you're looking to mark here to get full marks. One is the shape of the graph. So if you have that V shape on your graph, that's one of the things you're looking for. The second 2 are the points they cross on the axes. So the 0.75 and the 3. So if you get one of those 3 things right, you get low partial credit for 2 marks. If you get 2 of those 3 things right, you get 3 marks and high partial credit. Okay, so 2 of the 3 things right is high partial credit and 3 marks.
Okay, so Andrew, could you just say that one more time? Just two of the 3?
Yeah, so if there's the 3 things you're looking for here for marking are the shape of the graph and the
Yes.
2 points that it crosses. So
Yeah.
the point on the y-axis, the point on the x. And if you have 2 of 3 right, then you get high partial credit. Obviously, if you have all 3 right, you get full credit.
Yeah,
But
I
you
didn't
need
state
all
that.
3 for full credit.
Thank you very much. I actually didn't state that very clearly at the start. It does ask you to sketch the graph. So we do want to sketch the graph. A sketch that means it doesn't have to be perfect, but it has to have the shape of the graph. Okay, Andrew, thanks for clarifying that one. Okay, our last part of this one, B part 2. Find the complete set of values of x for which the modulus of 4x minus 3 is greater than 2 minus 2x. Okay, so what have we got here? Well, we have our V-shaped modulus graph. We have a linear y is equal to 2 minus 2x, okay? And we're going to ask ourselves, well, where is 4x minus 3 greater than 2 minus 2x? So basically, making it simple, is that saying to us, okay, where is the red function above the blue function for any particular value of x? So for instance, just as an example, if I was to pick just a point right here and to draw upwards, well, this would not be, actually this would be one of those ones, because again, the red function is above the blue function at this point. Okay, so that's how we're going to be looking at it visually in a moment. But what we can do here, different people will do different things, but you could square both sides, okay, to solve this. Or you can take what we call the plus or minus case, okay? And so the plus or minus case is shown here. And you're going to get 4x minus 3 is less than minus 2 plus 2x. 4x minus 2x is less than 3 minus 2. And when I solve that, I'm going to get x is less than a half. So I'm looking at the values to the left of a half. So again, this one here, which might be like 0.3 or whatever would be there'd probably be 0.1. That would certainly have worked in that case. So what we could do then with my other part here, I could say, well, 4x minus 3 is greater than 2 minus 2x. 4x plus 2x is greater than 2 plus 3. 6x is greater than 5. X is greater than 5 over 6. Okay, so here's my 5 over 6 here, and here's my 0.5, or my half. So, okay, so that those are my solutions, and it's worth 5 marks.
So this one's on a 0, 2, 3, 5 scale. So low partial credit here for 2 marks is solving to give either value of x. So if you solve either of the two inequalities and get either the x is a half or the x is a 5/6, that doesn't need to be an inequality. So if you solve it and get just your value of x, either of those would get you low partial credit for 2 marks there. For high partial credit, we're looking for both values of x. So if you wrote down x equals 5/6 and x equals a half, you would get high partial credit there for 3 marks. The inequalities then will move you on to the full credit. It's worth noting in this question that you don't need a graph. So if you just do this algebraically without the graph, that's absolutely fine. You can get full credit. The credit is awarded in this for the correct algebraic answers. So the graph is there for working and it's useful, but you don't have to have it to get full credit.
And Andrew, just before we finish this one up, let me just change my pen color here. I imagine there's quite a few students who are just wondering about squaring both sides. You know, that method of solving it algebraically. And I imagine a lot of students out there have done it that way. Is that just when I'm working this out? Is that covered in the marking scheme?
It's not, no.
Okay,
it's not covered in the marking scheme, but when you do that method, you will end up with the same values of x. What's actually given in the marking scheme gives you the two values of x, and then you go on to get those as inequalities.
Okay. Keep an eye on my maths here, Andrea. Is this when we bring this over, we're going to get 12x squared. What are we going to get here? A negative 16x. And what are we going to have here? A plus 5 is greater than 0, greater than 0. Okay. And so if you solve that inequality, okay, so you're going to factorize and solve, or you're going to let's just do it. So we know we're going to have a -1 and a -5 here at the end using our brackets method. And what are we going to have here? Well, we're going to have a 2x in the first bracket and a 6x in the second bracket, because if we look at that, when we multiply that out, I'm going to get 12x squared minus 16x plus 5. And again, now when I go from there to solve, I'm going to end up with my same answers. X is less than a half and x is greater than 5/6. Andrew, what do you reckon? Do we have it?
Yeah, perfect. And I would just say that from Owen's second to last line, so the 2x minus 1 by the 6x minus 5 greater than 0, if at that point you wrote down x equals 5/6 and x equals a half, that would be high partial credit. Okay, so in terms of marking using that method, you would be getting the high partial credit at that stage, and then full credit would be the final line.
Okay. Thank you very much, Andrea. That brings us to the end of question 5, and we're going on to our last skills question now. We're going on to question 6.